Welcome to session 30. This time around, what we are going to do is develop an interface that will allow us to map the efficient frontier onto factor space. When we talk about factors here, we make reference to both the French Feynman factors and the principal component analysis factors that we developed in previous sessions. So, what we see here is an interface, and that interface will allow us to do an interesting exercise. But before getting started, we need to load some commands that we've developed previously. One of them is, well, just the packages that we would need for data handling. We've developed a procedure for calculating optimal portfolios. Remember, you can right-click in any one of those code edit regions. And here's the commands that are underlying that button. So I'm going to collapse the region again, and I'm going to click it. And procedures for calculating optimal weights. Once we've done that, now we proceed to import the data that we will use. That data comes from Kenneth French's website. Let's just take a look at the website, and you will see that there is a section where you can find data. This is the U.S. research returns data, and we're going to be using the 25 portfolios formed on size and book to market. So we will just download them, put them in an Excel file, and we will import it. So let's go back again to our Maple document. So we will use the already well-known command import. Obviously, we'll need to calculate our mean return vector and the various covariance matrix. So we will just click, enter, and enter. So voila, all the information is already in the memory. Remember that you can go to the variables section of your worksheet in order to consult the data. You can also double click here and you will see the data entry here, or the same, the matrix can be explored here. So, well, now let's continue. We will need to download some procedures for generating the principal components and a customized package for multivariate OLS. We know that Maple has already a package for regression analysis, but as we mentioned in previous chapters, sometimes in order to accommodate our needs and to facilitate our coding, we can develop our own structure. So we put together some commands that fit better our coding needs. So now let's go to the results section of this interface. Okay, so let's look at each one of the four windows that we have in front of us. The first one is the efficient frontier. That efficient frontier corresponds exactly to the 25 portfolios. We can move the target returns. There you go. So we are moving along this efficient frontier. Now, what we have in this window is the weights of the 25 portfolios that correspond to a position or any position on the efficient frontier. So here it is. We can rotate. We can get a sense of what portfolio is short, what portfolio is long. There we are. Now, these 25 portfolios allow us to be on the efficient frontier. Yeah, if we take only the factors for building a portfolio, then what we will realize is that these factors will be able to produce some returns, but will hardly reproduce with perfection or exactly the returns that we will have on the efficient frontier. Something will be lost in the process, simply because all those factors are summaries of information of the 25 portfolios. It's not all the information in the portfolios. So let's look at what we have here. If we have this target return, let's say, which is thereabouts very close to 2% per month. Remember that this is monthly data. I'm sorry, yes, that's where we are here. It's 1.5%, let's say, 1.5%, right? Then the factor loadings will be long one factor, factor 1, short factor 2, long factor 3. But the R square that we are getting with those factor loadings is just 50%. We can go the PCA way. Remember that the principal components are just a way of summarizing or compressing information. If we put, obviously, the 25 principal components, our R squared, R squared will be 1. Okay, 1. And we will have some long and some short components, but this is just a matter of a definition because we can have the 25 portfolios or the 25 PCA. Now, the question is whether we can build factors and have a portfolio with more than 3 that gives us a closer result, or a result that it's closer to the efficient frontier, but without having all the 25. So an interesting exercise would be to start reducing the number of factors. Okay, now we have 17 factors, and with 17 factors, we have an R square of 84%. Now let's take it down, let's say, to about 13, 14, 15 factors, and it's 82, which is not too bad. Let's just go even smaller, and look at this. I mean, we can have 80% R square for a number of components, which is 9, 10, 11 components. So obviously 3 factors, which are easy to understand, clear to understand and interpret, it's a good way to approach building an efficient portfolio. But the problem is here that these 3 are, given the volatility of the underlying assets, it's not the best way to put together a portfolio. We may need to go the factor way and try to identify and interpret, which is the challenge here, a larger number of factors, but short of the 25. Now let's do a final exercise where we just take, let's say, about 6 or 7 factors, and let's see what kind of R square we get. Well, 76, which is not too bad. So with twice as many factors as the FF3F factor loading model, we can have a much better R square, and therefore we can get a sense that our portfolio will be closer or more efficiently benchmarking the efficient frontier. So let's take a break here, and we will come back in about 2 minutes. Thank you very much.